So hello everyone, this is Amit Kumar Jena, and I'm here to tell you about our research titled C1, Contextual Network for Sarcasm Detection. So let's see what it is all about. So this research was a part of the figurative language workshop, which was co-located with the recently held ACL 2020 workshop. So in this task actually, uh, you have to classify utterances as sarcastic or non-sarcastic, but we are also given the conversational context for each utterance that was to be classified. So the main goal for this research was to build systems that can effectively use the contextual information of a sentence to detect the sarcastic nature. Okay. So the data set which we actually used, it consisted of conversations from Twitter as well as from Reddit. We can also see some statistics here. Okay. So let's see an example from the data set. So in the data set, as I just said, that we have conversations. So let's start with the conversational sentence one or this context sentence one, which is C1. Then we have C2, which is a reply to C1. Then C3, which is reply to C2. Then C4. And then we have the response sentence. And for this response sentence, we have the sarcastic or non-sarcastic label. So this is one of the complete data set actually consisted of conversations like this, where we have the response sentence, it conversational context sentences, and then the sarcastic or non-sarcastic label. So let's see what kind of challenges which we actually face while working on this research. So sarcasm has a complex nature. So for example, let's see the sentence, your parents must be really proud of you. So just by reading it, we get a positive vibe, or we see that it's a positive sentiment word. When we see the context sentence, I spent all my money for partying last night, and then we see this sentence as a reply to this context sentence, then we can clearly see the sarcastic intent of the sentence. So as we saw, this conversation context can help a lot in deciding the sarcastic nature of any sentence. Another challenge we actually faced here is that, as we just saw in the previous example, that we have context sets consisting of conversation context sentences. So the size of this context set was not fixed. It had variable sizes, and from this figure we see that the size of context set ranged from 2 till 20 in case of Twitter, and in case of Reddit, it ranged from 2 to 6. So we have variable context set sizes. So in our examples, we specifically use the last two sentences of the context set. So which were the most immediate context sentences actually. Another challenge which we actually faced here is the platform which we use to express sarcasm. So for example, in case of Twitter, we have a very limit on the number of characters which we can use, and we can also use some kind of emojis to express our emotions. But that's not the case with Reddit, right? So making a generalized model which can detect sarcasm for both these platforms can be a difficult task, right? So let's see what's the proposed model and the intuition behind it. So sarcasm detection in a conversation has situational dependence on context. It can be seen from the previous related works. So also we just saw in the example that we have no labels for the context sentences. So what we propose is to give them pseudo labels. So what are pseudo labels? Giving the context sentences the same label as that of the response sentence. The intuition behind doing this is that to train the model to detect situations in conversation which can generate a sarcastic sentence in the near future. So what we are proposing is this. If the response sentence has sarcastic label, then we give the same label to all those conversation context sentences. So how does it help? Let's see. This is our proposed model architecture. As we can see, we have n+1 models. Then we give the complete conversation as input to these models, and then we get the final. So here, n is the maximum size of the context set in the data set, and all these n+1 model are bird based on case models. So in our experiments, we actually use till model 3 since we are using just the last two sentences of context set. But as we can see here, our proposed model architecture is capable, or it has potential to use the complete context set. So what we are trying to do is, after training all models with pseudo labels, we are trying to assign scores to all the sentences in the conversations. So for the response sentence, the associated score is Pn+1. So Pn+1 is the probability of response being sarcastic. And for P1 actually, there's a different meaning a little bit. So P1 is the probability of response being sarcastic if this context sentence 1 is present in the conversation. Similarly, P2 is the probability of response being sarcastic if context sentence 2 is present in the conversation. Similarly, for all context sentences, the meaning of the probability value is the same, but it is a little bit for the response sentence, right? So after generating all these probability values, we are using them in the fusion layer. So this fusion layer can be either logistic regression or a SES model. So we got a little bit better score in SES. So why we are using SES? Let's see. So let's start with the response sentence. Just by reading this response sentence, we are not getting any idea about its sarcastic nature, right? So just by seeing the most immediate context or the last sentence of the context set, we can actually get a lot of idea about the sarcastic nature of this response sentence. And as we go deeper in the conversation, the influence of the sarcastic nature over the past sentences in the conversation starts decreasing. So SES always ensures this. As we go deeper into the history of the conversation, SES always ensures to give the decreasing weights to the most past conversation context. So SES always ensures this. So that's why we use SES. So these are the results which we got. As we can see, CNET plus SES got the best results in case of Twitter. But in case of Reddit, we got the best results on the Roberta model, which was trained only on the response only set. So it's quite counterintuitive to the fact that conversation context helps in detecting sarcasm. So why it's happening? So we propose that the kind of flags present in the data which are helping the model in detecting sarcasm just by seeing the response sentence. So these flags can be either unusual punctuation marks or capitalized words, and these flags can be there in the pre-trained data of the models, right? On the data which was used for pre-training of the models. So we propose that if we train the model on the target data sets, then the accuracy can increase. Also, as future works, yeah, we are trying to investigate approaches that can deal with variable context set sizes. Okay. So what are the applications of CNET? So any kind of task which requires some kind of contextual information, like humor generation or emotion detection, CNET can be used there, right? Okay. So this is the link to our paper, and this is also a link to our code repository. So if you have any doubts, please consider reading our paper once, or please feel free to mail for any doubts. So thank you for listening, and have a nice day.